All right, folks, welcome back. We are in the Human Capital Development track, and we are going to hear about the Capstone Marketplace, which is one of, honestly, my favorite projects in the SERC. I think they do great work, and the best part is there's a lot of student engagement, so always fun. You're going to hear from Captain Bill Shepard today. He is a retired Navy SEAL and United States astronaut. Starting in 1993, he served as the program manager for the International Space Station. He retired from active duty in 2002 and served as the US SOCOM Science Advisor from 2008 to 2011. Captain Shepard joined the SERC several years ago and has made a number of contributions to critical research. Again, for the last several years, he's led the Capstone Marketplace, which he is going to talk about today. So thank you very much, Shep, for being here, and over to you.
Hey, Nicole, thank you for the intro. I hope my audio and video is coming in strong.
You're good, Shep.
Okay, I'm going to do a little screen sharing here. I'm going to talk about a program that's been running for 8 years as part of the SERC, the Capstone Marketplace. And it should be up right about now. So I manage the Capstone Marketplace, which is hosted by Stevens, but it's really a SERC project with Michael DeLorme. He's another researcher at Stevens, and he and I basically handle most of the administrative work of getting the capstones off the dime. For anybody that's not familiar with what a capstone is, I think most of the audience probably has done capstones in school, but these are a relatively recent introduction to university education in that they are across all different departments in schools. You can find people in business school doing capstones or other academic departments. Law school does capstones. So it started out as senior design projects in some of the more applied engineering disciplines like aero and maybe ocean engineering, but now they're everywhere. A lot of times the professors will select the teams and even develop and assign projects on their own. And some of the capstones that universities pursue are studies and papers. And some schools are fairly successful at attracting industry participation in assisting the student teams do their capstones. We have a different approach at SERC. I'm just going to highlight some of our differences. We connect the university, the faculty, and the student team with military operators, hopefully in units that they're not responsible for research and development. They're out operating, they're doing real things. So the students have an opportunity to connect with real customers who have real problems. We do typically 2 semesters of project work, but we lay in an element of common business tools that these students will find in industry. We conduct 4 design reviews during the year, and these are reviewing the schedule, the costs, and also the team's technical performance, much as what would be done in a small startup business environment with some venture capital funding. We do have some contact with industry. It's a road that we have had a little bit of difficulty going down, but it's something that we'll do more of in the future. The last part is probably the most important. SERC capstones are being done in part to solve problems for people, and we insist on real tangible deliverables. They can be hardware or software. And we like a prototype, we like a demonstration. Some university capstones don't have this requirement. In the larger scheme of SERC's charter, SERC has 4 thrusts that you've heard about. Our emphasis is on the human capital development, and our attempt is kind of the bottom of the slide here. You could take the thesis that the world may not need a whole bunch more system engineers, but they probably need a whole bunch more engineers who know something about system engineering. So we've debated this inside the SERC, and we've kind of come up with the tactic that the way to do this is to catch young engineers as undergraduates before they graduate and give them a little taste of what system engineering is about and why we have it. By the numbers, this is the 8th year we have done Capstones. Highlights from last year: 27 project teams, 9 universities, 5 schools that were not members of the SERC. We have a special accommodation from OSD to basically deal with any university that is accredited in the United States with these projects. We spend about $4,000 per student team, and we reached around 125 student engineers last year. We are starting 23 new project teams this fall. We've got them all underway, and teams are marching right now to do their development work. I'm going to go through that in just a second here. Last year, I'm going to highlight 2 of the more interesting capstone projects. University of Texas at Austin did a device called the self-intubating airway. And the idea here is that the military operators are often in combat situations, and they can have people who are wounded who need an airway established. But sometimes it's really difficult to get this done because bullets are flying. It's the middle of the night. In a typical clinical setting, a medical personnel would have to position the patient, would have to illuminate the throat area, and have a pretty good technique to get the airway established. And in combat, a lot of those factors are not available to you. So we had a request from the Army. Is there a way to develop a device that'll do this automatically? This is the 2nd year we've run this project at UT Austin. It's very promising. You're looking at a CAD representation of the prototype that they built. It's a turret that spins around, and there's a motor-driven spool in the middle that drives the tube. It's called a bougie. I guess that's French. And so far, it has been tested on mannequins, and the design is pretty ingenious. It's developed to the point where we're going to do it for a 3rd year. The project's underway again this year at UT. I think this is going to be one of the more interesting projects that'll probably transition not only to government, but probably the medical sector as well. Another capstone that we've worked, very successful with University of Alabama at Huntsville. The Navy operates a small submersible. It's a modified research submarine. It's not really laid out initially for some of the missions that the Navy would like it to do. And so one of the desires from the Navy customer was to figure out a means to store equipment, be able to seat personnel where they could relax, and basically make better use of the internal volume. The team in Huntsville did a very good study, several prototypes. They were tested by the Navy. The Navy really liked them. And now this particular design has been taken up by the Navy, and they're doing a production transition for this. And the Navy is really on board with doing more capstones because of the success that they've had last year with this project. Quick look at what we're doing this fall. Up at the top, most of the projects all the projects you're going to see on this page have to do with a small submersible that the Navy is operating. We have 2 teams working on detecting gases that the sensing system that exists in the submarine does not detect now. Some of them are principal ones that we're interested in are methane, hydrogen, and carbon monoxide. We've got a team designing some type of breathing support outside the submarine for divers who may be running low on their gas supply in their scuba gear, and they need to breathe something as they're preparing to get back into the submarine. 2 studies on the long duration fatigue and some of the issues with the crews on these submarines trying to drive this thing around for what could be days at a time, how to facilitate their crew rest and their duty cycles and even their diet so that they are less subject to fatigue. Designing stowage pods that would go on the outside of the submarine for more volume for equipment on missions. The submarine can operate in different seas and oceans, and sometimes ballasting the submarine and getting its buoyancy right is somewhat of an issue. The base design of the submarine is not configured to do this. So there's a project underway at the Naval Academy to try and accommodate water, if you will, of different density as the submarine is operating. A tow cable that can pass communications, data, and maybe even electrical power up and down the tow cable. The 2 projects at the bottom have to do with understanding the configuration of the internal systems on the submarine as you dive and when you're looking at what has to be maintained or renewed as the submarine is operated over a long period of time. The next page, these are Army and Marine Corps projects. Electrical service monitor as a way to analyze what the electrical load or the power usage is in buildings, generally in a rural or suburban environment. The working dog analyzer is building on a very interesting project that was done last year at Stevens, looking at the response of the eye, particularly the iris, to flashes of light. And we think that this and some other biometric sensors will be very applicable to understanding the stress, the fatigue, the anxiety, the general condition of working dogs. The Army's very interested in this. We have a project underway to adapt systems that recharge small quadcopter drones for military use. We've got a sensor network project going. This will be used it's basically seismic and acoustic and probably the integration of video sensing to create a hasty security perimeter around places where the military units camp for very short periods of time, maybe a day or 2 or 3. It has to be very self-contained, lightweight, portable, all the good stuff. Ways to quiet down quadcopter drones. 3 teams are working on that. The Marines are chasing 2 augmented virtual reality projects. And again, Stevens is continuing the traumatic brain injury measuring, and they've been very successful at developing the phenomenology, and this year driving toward a more mature prototype. We've already talked about the Texas work on the self-intubating airway device. 23 teams, and that's what Capstone 2122 looks like right now. So the timeline, we are starting the kind of in the middle of the fall semester in the early November timeframe. We've had our first design review on most of the teams. We're looking at a second design review right before the Christmas holidays. We'll have 2 more Capstone design reviews in the early spring and then at the end of the second semester when the academic year closes out. And we tend to try and identify our research topics mid-April, and we get our topics up on a website that we run by the close of school, ideally. And then over the summer, we have expressions of interest from faculty and even students saying that they would like to attack a certain problem. And then we go off with down selecting the universities and trying to figure out how to write subcontracts from Stevens to each university's business office. We're looking to have a Capstone summit meeting sometime in the spring, conditions permitting. We did one 2 years ago, but because of the present COVID-19 restrictions, we have not been able to do that for the last 2 years. Okay, what do the students get out of Capstones? They have contact with people who are really interested in their solution. They don't have to invent anything. Their professor doesn't have to make up something for the kids to do. And we think it's a pretty good introduction to system engineering thinking. We try and keep the overhead for all the processes that would go into a normal system engineering effort to a minimum. It's a very light touch, but we do model what the students can expect when they graduate, if they go to work in industry, as far as what their managers are going to expect from them as far as the performance of a team. And then at the end of the day, we really want to see that the students have built something and that they're able to demonstrate it to their customer. What does DOD and the military and other government entities get out of this? Well, we typically talk to people at fairly low levels in operational organizations. We don't really go to formal R&D labs. We are dealing with people whose primary job is not to go build stuff in the government, but they have good ideas. And so our approach, we think, energizes innovation in these organizations. And we also often get the best ideas from the low-level personnel. And many things that they come up with are really unconventional and out of the box. We tend to get a lot of bandwidth for not a lot of money. And we already talked about our project ceiling is normally $5,000 for 2 years. And then each unit can, even if they don't have a home run with their capstone project and their prototype, the effort does build a very good library of technical data on key subjects. And we've already talked about trying to identify and cultivate government MacGyvers, if you will, who have an interest in innovation and who want to work on more important projects. But I think the biggest thing is probably the last one, where we introduce students to what opportunities are out there in the DOD and the government to do work on this kind of R&D, and we have very good response from our students in that regard. Capstones, this is the SERC network today. And we've worked with all the following universities in the purple box here who are not in the SERC consortium. And as I said before, we've got authority from OSD to work with any accredited university in the US. And we've got a lot of traction actually with the smaller schools. Some of our key customers, our Navy and our Army customers, have said things like the following. One project, students outperformed a warfare laboratory that had been involved in the same project for over 10 years. I like that one. And a fairly recent one, this has probably saved us $1 million. This came from a Navy commanding officer. So how to learn more? We're available through email, myself at Stevens, and Mr. Mike DeLorme at the bottom here. And then we have our website, which are free to browse, capstonemarketplace.org. You can join our website and see more detail, but we only take emails from accredited domains. If you send us an email with a Gmail domain or AOL, we'll probably send an email back to you saying, give us your school.edu address and we'll respond. So, questions?
Shep, thanks so much. Like I said in the beginning, this is always one of my favorite tasks. I love what the students do, the creativity, the innovation. I just love it. For if you have questions to come in through, I just have kind of a silly question, but I'm curious. What's the favorite student project that you've worked on? or that you know has been part of the Capstone marketplace in the last 8 years?
Actually, the favorite one was the one where the students, we had two teams a couple of years ago, one from the University of Alabama in Huntsville, another one at Stevens. And they worked on a project for the Navy where the Navy often has to basically go check out civilian vessels, particularly in the far Pacific, in the Mideast and whatnot. And these are either recreational or small fishing boats, or and sometimes these vessels are very difficult to constrain, if you will. You don't want to do damage to the boat because you don't know if they're legitimate or not, but you want them to stop doing what you're doing. So the Navy asked if there was a way that a device could be developed that would basically net or snare these boats so that they couldn't maneuver away while you're trying to find out what they're doing. And the two teams, they worked on it for a year. One team was okay, successful. The other team knocked it out of the park. I think we spent a total of $10,000 on it. And a government lab had worked on this for almost a decade, and we had spent $500,000 on it and got nothing. That's my favorite project. So It's not typical, but it happens. And that device right now has been replicated a bunch of different times, and it's available to the Navy right now. It's deployed. It's ready to be used in the manner the Navy wants to use it. To me, that's a home run.
Yeah, no, that's absolutely a success story. Let me ask you, well, one comment, I suppose, before I ask the question. You know, you mentioned that not all of them turn out that way, but we're talking, you know, $5,000, $10,000 compared to what the DoD normally spends on acquisitions. So in terms of return on investment, even if you only have one out of every 20 teams that does well, it still seems like you would learn a lot for a relatively small dollar amount.
Yeah, I think you have to really take in the whole scope of the benefit too. We've got a couple of students that have been placed in Navy labs. One student in particular went to the Coastal Systems Center down in Panama City at the end of this academic year simply because he had such interaction with experts down there. They said, hey, how about you interview for a job when you graduate? And they hired him. I mean, that in itself, it's really hard to put a value on it, but it's really important. And so many of the kids that we interact with come back and they say, well, hey, you know, who do I have to talk to when I graduate to do more of this in their professional careers, which I think is awesome. So it has a lot of benefits.
Yeah. Are there any formal metrics that the program's tracking along things like that?
We're kind of struggling to get those. Typically, we don't officially track what the student. Probably the best metric we could come up with would be number of students and what happens to them after they graduate.
Sure.
We typically don't track that, one because it's kind of manpower intensive, and two, I think we'd have to have a lot of approvals from the university because it's kind of personal information. So I don't know, and we've kind of just said, well, that's in the too hard category for right now. To be honest with you, our focus at the moment is to keep 23 teams from running off the rails, and it gets to be a full-time job. So
Sure.
I know it's kind of whining, but that's what keeps us busy.
No, we all have to deal with that part of things. But, you know, one of the challenges you hear all of the time whenever you're discussing workforce issues in the department is, you know, we can't offer the salaries that industry can offer. And so even if you're getting a few really good, interested, enthusiastic people willing to say, this is the kind of work I want to do, I'm willing to accept that it's a lower paycheck to get to do these types of things, I think that's a win.
Well,
I just appreciate
I do sense from the kids that they get a lot out of having a customer who appreciates the value of what they did in their research. And that's really important to them. So, and then
Yeah.
we're pretty successful at doing that.
Well, Shep, thank you so much. Like I said, love the project. Look forward to hearing all of what their student teams from this year do at our next event. And you provided your contact information, so I'm sure folks can follow up if they have questions, or if any of you out there are from a government agency that have a really great problem that you'd like for some of these student teams to maybe tackle, please reach out to Shep. So Shep, thank you so much for your time. Folks, we are going to move into a break, and we will return for the workforce development track at 3:55. So thanks again, Shep, and we'll see you all back here soon.